Here are the dilutions we made in the lab. To start, we transferred acceptable amounts of the dilutions as well as some water to the cuvettes and went to the spectrophotometer room. When using a spectrophotometer, it is important to scan across all wavelengths to determine what range of wavelengths the sample actually absorbs at, as well as the peak absorbance of the sample. Scanning across all wavelengths will generate data that can be graphed with absorbance on the y-axis and wavelength on the x-axis. While scanning across all wavelengths, the sample will absorb some wavelengths better than others. The result will be a continuous plot that has a defined peak at some wavelength lambda. This defined peak is referred to as lambda max because it is the wavelength of light that the sample absorbs the most. We begin by wiping our cuvettes with Kim wipes as shown. We then zero the spectrophotometer with water as our blank, and follow by measuring the dilutions. For this lab, our TAs did not have a scan across all wavelengths, so we were told to scan at 650 nanometers. Also, it is important to close the lid before measuring. Based on Beer's law, absorbance and concentration are directly related, meaning they have a linear relationship. Failing to zero the spectrophotometer with a blank will make the absorbance appear higher than it really is. When you zero out, you are setting whatever absorbance the blank has due to impurities to zero, so that absorbance won't be counted in the actual solutions. Once we measured and recorded all the dilutions, we calculated the molarity of the unknown, and then we cleaned everything up.